2w plus 5x plus 4y minus 2z equals. Okay. Um, yeah, we'll just do this. This is okay. Um, this is different than the solution they have. Is that okay, or do you want us to be consistent with the solution?
Um, we can go ahead and do what they did. Looks like
Okay,
what
because
they did.
it's
Yeah.
slightly different. So it's like what they do is they recognize back in the original system here, they recognize that because we got it down to x and z, if we use this fourth equation, we might be able to do the same thing. We might be able to get rid of x and get it down to x and z, because when you multiply this fourth equation by -2, 6x minus 4y minus 6z equals 34. And then you
It
bring
cancels
over
out
the,
yeah, it cancels out W and Y.
yes. Now I didn't see it, and I do this all the time. So I don't think that should give you a lot of confidence that you would notice this. Meaning that not nothing against you. It's just, that's why I'm sort of scanning the solutions to be like, I wonder, we're gonna get to the same place. You don't. Now we could have still worked it out, but the whole goal with a big system like this is to turn it into something where it gets down into, in this case, two equations with the same two variables. So your new system is 9x minus 3z equals 30, 11x minus 8z, which is 54. Okay. And so if you're okay with where we are up to this point, this is an equation, two variables, two unknowns. None of the coefficients lead to the other one. 9 doesn't lead to 11. 3 doesn't lead to 8. So you just have to multiply both equations. Okay. So I'd like you to solve this from here. And it doesn't matter which variable you eliminate or solve for, but you are going to multiply both equations. So I think your tendency has been to eliminate the first variable. Really doesn't matter. With big numbers, 11 and 9 or 8 and 3, kind of up to you. I would go 8 and 3 just because they're smaller numbers to deal with. But that's kind of up to you. But go ahead and solve this. The numbers do work out nicely. These are the correct equations. Let me know what you come up with.
Wait, so I do have a question. When
Yep.
you're multiplying on the top or the bottom, you don't need to multiply by the same number, right?
You do not. So if it which variable are you trying to eliminate?
I was trying to eliminate Z by multiplying 8 on the top and 3 on the bottom.
Okay, so one of them has to be positive and one has to be negative when
Yeah,
they're the
or it
same
would have to be
size.
it would have to be like -3 or something like that. Yeah.
Okay, so it's never this. Well, it's rare. It should never be the same number because if they were, then you would end up just adding them. So this is what you're multiplying. Is that okay?
Yeah. So I got x=2.
Okay. Like I said, they both work out nicely, so that is correct for X. Why don't you solve for Z, and you can use either equation for that.
I got z=-4.
That is correct. All right. So the nice thing is once you have these two variables, you're in really good shape to find the rest. Now you got to kind of go back. Like let's just say you were really creative and you knew to go to these two equations. You would have problem solving for the other variables because you still don't know what W and Y is. And if you go back to those two equations, you'd have to substitute it in. But because we actually were able to combine these two, we can find Y using this third equation that we found. And once we find Y, you can use any of the equations to solve for the last variable. So why don't you use this equation and solve for Y, please?
Right. I got -36.
Definitely not. Let's take a look here. So we got -2 minus Y plus 4 times -4 equals -18. These they like that could be an answer, but they're generally designed in such a way that they're they're smaller numbers. So like we have -2 minus y plus -16 equals -18. So this becomes -18 equals negative y, -18. So now you add 18 to both
Oh,
sides,
yeah, I didn't see the
right?
negative on the other
Yeah.
side.
So y ends up being 0. And then
Yeah,
you
I
have
didn't.
your,
Yeah, I don't think I saw the negative on the other side of the equal sign. I thought it was positive
okay,
18. That's why.
right.
Yeah,
And then you get your pick of equations now. Like which one of these would you use to solve for w? So like to me, that one's out because
you could
it's
use the
got
positive
coefficients.
W one.
Yeah, I
You
would
could
use
use
that
the
one there. So
last one.
yeah, so you please use that to solve for w. And then we're going to look at number one on your own together because it's more most like this one.
I got W equals 1.
So good job on that. If you get one on a test, I mean, these are pretty time consuming. I mean, little startup time. It was probably, it's a 15-minute question. Uh, that's a long time. We want to get this a little faster than that. Now, what I noticed from the first one that we did is that you have to sort of look ahead. Like if I combine 1 with 2, 1 with 3, 1 with 4, okay, 2 with 3, 2 with 4, and 3 with 4. You have to sort of like look at all of these possibilities and be like, what happens when you combine them? Okay. Now, like I was drawn to the first one by like it's like last time where the first two they combine and you almost want to make a list of like what variables remain when you combine them. So like 3 and 4, when you combine them, you get an X, a Y, and a Z. Okay. This is okay. It's not great. Um, but this one is like the one we just did, where if you combine them in a certain way, okay, for example, see how this equation's got the minus in front of it again?
Yeah.
So if you multiply it by 2, you get minus 2y, which cancels with this one, right? Cancels with the first equation, the y, and you get rid of the
Yeah.
w. So when you combine 1 and
Got it.
3, you can get it down to
Wait,
x and z
actually,
again.
never
Go ahead.
mind. Actually, never mind. I was gonna say that the Z would cancel out too, but it actually wouldn't. I was looking at the other two equations.
Yeah,
Um,
and so, but like, well, what else? Well, let's say you multiply it by, let's say you multiply it by 4. Is there anything else you can combine it with? Well, you get rid of the w, but there's nothing else there. So then maybe you turn your attention to this equation. W,
couldn't you, yeah, couldn't you do multiplying it by, actually never mind. I was gonna say multiplying it by -1 for the second and the fourth equation, but it wouldn't work because we'd only be able to cancel out actually wouldn't be able to cancel out anything. It would have to be the actually never mind. I was gonna say you could cancel out like you could cancel a Z though with the second and the third.
but that doesn't help us because we really like we're trying to get it down to 2 variables. That's really ideal.
Got it. So yeah.
So
Two.
again, like it's kind of like the last one where, okay, like look at the fourth equation. If you multiply it by negative 4, you get -4w,
And you get
-8x,
-8.
-8y. That cancels with that one.
Yeah, so you can cancel out the 4 and also the y. The 4 will survive
Yeah.
the index. 8y.
So that tells you the points. I mean, and I mean, it helps having me here telling you this, right? But like that is probably the best way to do it, is to sort of like look ahead, not just try a bunch of stuff. So um, let's do that here. We're going to take this this equation right here. And I guess I have the advantage that I can keep nipping it in, which really does help. So let's take this equation and multiply it by 2. That's negative 2w minus 10x minus 2y plus 6z equals 16. And then let's take this equation here, 2w plus 4x plus 2y minus z equals 1. Add them together, negative 6x plus 5z equals 17. Similarly, we're going to take this fourth equation, multiply it by minus 4, minus 4w minus 8x minus 8y plus 4z equals minus 8. Grab this equation. Okay, we're going to add these together. Minus 5x minus z equals 11. Any questions on that? Thoughts on that?
No, I think I get that.
Let me double check these because uh, the any mistakes here get propagated through the rest of the problem.
Yeah.
It's worth an extra minute here for me to just check before that happens. This is a plus. It's a plus z. That's a mistake. Check this other one. Okay. Negative, positive, positive. Okay. All right. So this looks okay. So we have minus 6x plus 5z equals 17, minus 5x plus z equals 11. Which variable do you want to eliminate in this example? What makes the most sense to you?
Probably the z.
I would agree, because you're only multiplying one equation, the second equation by negative
Yeah.
5.
Yeah, that seems like the most logical one. So you
All right, this
multiply the
that
second one by
yeah. Yeah, so go ahead and solve this for x and z. I've got the solutions up. They do work out nicely.
so let's see, negative 6. What about x equals -2?
That is correct. And then use that number to solve for z. I would use the second equation.
Yeah. I got Z equals 1.
That is correct. Okay, so if we go back to the original problem now, and this is where that table I made initially really helps, like combining the equations. Like you want to get W and Y next. So you want to go back to your table and be like, well, is there something that I can combine to get it down to just Y or W? And 3 and 4 are the right ones because you get an X, a Y, and a Z when you combine these two equations, but you already know X and Z, which means you can quickly solve for Y. So these two equations here, when you add them together, you get minus 3x plus 1y plus 2z equals 10. And you can put your z value in, your x value in, and you can solve for y.
All right. Leaving. I got Y equals 2. So
Okay. All right, so now, which equation are you going to use to solve for w?
the last
Which
one.
one? Yeah, the last one makes the most sense to me because it's got w with a 1 in front.
I got W equals 3.
All right, very good. Okay, so that one was a little faster than the previous one, but you can see they still take quite a bit of time. Do you want us to keep working on these or do you want to transition to a different topic?
I think continue working on these because this is what I mainly went over.
All right, sounds good. So we got to kind of do the same thing we were doing in the previous problem, which is look at all the possible combinations, 1 and 2, 1 and 3, 1 and 4, 2 and 3, 2 and 4, 3 and 4. It's like, okay, what happened? Like, does anything stand out? Like, does anything show up? And so, uh, you know, like, do you see kind of what you're looking for is two equations that have two variables that are multiples of another. Like, what I mean by that is like, trying to think here, which one's the best example of that? But you'd like to ideally eliminate two variables. So, if you multiply, and it may not be possible, like if they don't all work out like that, where you can do that. Um, if you multiply this one down here by -3, see how it would cancel with the 3w? What other variable would it cancel with in this equation?
If you made one of them negative, then you could cancel out between 2 and 3. You could cancel out the
No,
W
no, no.
and the Y.
Not two and three. I'm talking about if you multiply this equation by -3, and maybe
Uh,
that's what needs to happen here. Like you're gonna have to actually multiply these, even though it takes a lot of time to write this out. Uh, what would this equation cancel with and the other ones?
um, you could cancel out W and Y with number
Yes.
two
And any of the others?
and number three. I think should be
Yeah.
all.
Yeah. So that's you got to know that. You got to look ahead to see that. And I don't know how to tell you to do that. Like it's sort of like looking over and over, like which variable do you cancel out? Maybe your teacher will give you a hint. I mean, these are tough. These are really tough. So if you do 1 and 3, I'm sorry, if you do 3 and 2, sorry, boy, that's wrong. You do 4 and 2 and 4 and 3, those are both going to get you down to X and Z again. So this time I want you to combine this with 2 and this with 3 and let me know your new system of equations. Or let me know when you've got it and I'll do the same. That way you can.
All right, for 2 and 4, I got negative
Okay.
2x plus 5z equals 50.
So you said 2 and 4.
Yeah.
Okay, so that's -10x plus 5z equals 50.
Oh,
Good.
wait, right, I forgot. Yeah, just gotta do a small step. Yeah, and then for 3 and 4, wait,
About 3 and 4 now.
yeah, but doing right. Um, I got negative 14x plus 10z equals 82.
Okay, looks good. Um, hard here not to multiply the first equation by -2. What I would do here to solve for yeah, or to eliminate z to get x. Let me just double check that this one actually worked nicely. It is so easy to make mistakes. Are you guys doing any calculator stuff in the classroom?
Um, I don't think so.
Okay. So I would recommend eliminating z by multiplying by -2 here. And go ahead and solve this for x and z for us, please.
I got x equals -3 after eliminating z.
Okay, that is correct. Go ahead and back substitute and solve for z in either equation.
I got 4 for z.
That is correct. Okay. So we're now trying to find y and w. So you go back to the original, set of equations here, and you're like, is there a way to combine the equations so that you get it down just to y and or w? And so I think you kind of, let's see here. What did you say earlier? You said something about combining like 2 and 3. 2 and 3 gets rid of x. We really want to keep the x. But if you subtract them, it gets rid of the w. And that's just one idea. Like if you negate this one so that it's -3w plus 2x plus 3y minus 4z
Wouldn't you
equals
get rid
minus.
of wouldn't you get rid of y then too?
Good point. Yeah, we don't want to do that. So that doesn't work. So here's the other way to do it, which isn't the best, but it does work. Is you actually put x and y or whatever these numbers and you put them into the equation. So I'm just going to do that in the first one. 5w plus -3 plus 2y minus 2 times 4 equals -13. So what this does is it gets it down to two variables. It ends up being 5w plus 2y. This is -8, -3 is -11. So you add 11 to both sides and get -2. And then you similarly make maybe put it into the last equation there. I don't really have there's doesn't really matter, but w plus 4 times -3 minus y minus 2 times 4, okay, equals -19. So this is another option. So this gives you w minus y equals -12. -8 is -21. You add 21 both sides and you get 2. But that always worked. And I don't love that approach because it you can potentially um make more work for yourself if you this didn't I made a mistake here somewhere. 5, 2, 1, -1. So I made a mistake because this doesn't work out nicely. And I know I'm pretty sure these work out nicely. -12. All right, so this is a 1. I think that's the issue there. And now it does work out. Works out. Yeah, it does work out nicely. Okay. So I'd like you to solve, these two, the system of these equations for us, please.
Got y equals -1.
Correct. That means W ends up being 0. So kind of a small thing is your answer is in the answer that the variables appear, usually
Wouldn't it be
alphabetical
in,
order.
yeah, that's what I was gonna ask. It would be usually be in alphabetical order.
usually. -3, -1, and then 4. So I didn't do that in any of the other problems, so just keep that in mind. All right, so this last problem here, what I want you to do is spend like 3 minutes here at most figuring out which equations you should combine to get it down. Let's see here. 2 and 3, 2 and 4, 3 and 4. All right, so take some time here to see if you can figure out. And actually, I don't know what this means. That could be a problem. Let me solve the system myself with a computer here and see if I can
Oh,
give you a.
she did mean that the kind of negative looking sign above it, that was just like a mark that was printed on there. It's not, that doesn't mean.
Okay, so it is plus.
Yeah.
Okay, all right, good enough. So take some time here, see if you can figure out which equations to combine to get it down to the same variables. All right, so I'm going to jump in here because there actually doesn't appear to be a way to get rid of any of the variables, at least as far as I can tell. Um, what I do see is some good stuff going on with Z down here.
Yeah.
I don't know if you're drawn to that either, but what I see is that if you like add the first two and multiply these by 3 and add them to this one, that works out. Not the greatest.
Yeah, you,
You could do the W thing where you eliminate W. It doesn't look like you're going to do better than a 3 by 3 though. 3 equations and 3 unknowns. Although if you eliminate W, you might get it to where you got a negative X-ish, you know. I don't know. What do you kind of see here?
I definitely thought it was the Z thing, but I thought you could do 2 and 3, but yeah, you probably can't because if you even if you were to multiply it by 3, the second
Yeah,
equation, then
it,
yeah, that would work.
that W doesn't go away. Yeah. So this may just be that one. So, I'm not sure what's just, but let's just eliminate the Z just to see. So let's combine 1 and 2. So you end up getting 9W plus 8X plus 5Y equals 44. And then I'm going to take 3 times this third equation and add it to this one. So that'll give you 6W plus 22X plus 11Y equals 19. Not great. Let's do the same thing here. So then the same thing here. So 3 times this one, and we're going to add it to the second one there, which, I mean, I don't know, maybe it's better to subtract. Yeah, it actually is. We should take, yeah, it really would be. So we did 2 and 3 here. And I'm gonna do 3 minus 4. And you're gonna see why here in a moment. It's gonna give you minus W, 6x, 7y, and positive 4. Let me check that this actually worked. So what you're looking for is that like -1 or 1 in the first position. Really does make a huge difference. Yeah, this works. Because now we can for sure get rid of the W, right?
Yeah.
We can multiply this equation by 6 and then by 9, which, I mean, it's not great, but that's what it would be to be able to solve this. So when you multiply by 6, we're getting to a point where you really almost need to write this out. Plus 36x plus 42y equals 24. Then you're combining it with this one. It's not uncommon for these to take up multiple pages. So that's 58x plus 53y equals 43. And then we'll multiply it by 9, you get minus 9w plus 54x plus 63y equals 36. Then we got that 9w plus 8x plus 5y equals 44. Mind those. So end up getting 62x plus 68y equals 80. Let me just double check that this actually worked. There's sign errors. It does work. Okay, so I will leave you to think about that. You can solve that for x and y. Great. You would then pick one of these equations to solve for w, and then you would go back and pick one of the original equations to solve for y. And the final answer is not on my screen. I'll give you the W. I can tell you that W is 5, X is -2, and Y is 3. I don't know what that means for Z. You can figure it out, I'm sure. So I would redo the first few problems we did, not the last one, if you're looking for some extra practice.